Okay, good morning, everybody. I am Pierre. I'm working in Eurotech. Eurotech is the company that has given the Eclipse Kura framework to the open source community. We started developing this kind of tool maybe 10 years ago, and 2 years ago we decided to open source a part of the framework. So I will try to explain a bit more what is exactly Eclipse Kura, how you can use it, and I will try to be very practical. So for that, I take an example of connecting a BLE. BLE is a Bluetooth low energy device to the cloud. So the first question that I could have is why should I connect my BLE device to the cloud? So we are now in the Internet of Things, so every device should be connected to the cloud and should be able to deliver its data to all the consumers that need this data. So that's why I would like to connect my device to the cloud. And how I will connect it? So, of course, a very small Bluetooth low energy device cannot connect to the cloud by itself. So we will need what we call in Eurotech a multi-service gateway, which is an intelligent platform that is able to take the data from the field, send it to the cloud, and to be managed from the cloud also. So that's what I will present today. So what do I need to connect my Bluetooth sensor? So my gateway will be, in this case, a Raspberry Pi 2, which is quite easy to find and not very expensive. I need a Bluetooth dongle that is compatible with a Bluetooth low energy, so you need to buy a quite recent one. And I will try to use these small devices from TI. TI has produced some very small sensor tags that are quite interesting. These are Bluetooth low energy devices, including a lot of sensors, temperature, humidity, etc. The latest release is really rich in sensors. There are 12 sensors in it. So we will try to connect maybe the temperature, pressure to the cloud, just to know exactly how cold is it. So first thing that I need to do is to connect my Bluetooth sensor to my Raspberry Pi. My Raspberry Pi is running Linux. Unfortunately, at the moment, the Linux running on the Bluetooth, on the Raspberry Pi is not really fully compliant with the last release of the Bluetooth stack for the Bluetooth low energy devices. So we need to install first the Bluetooth stack module. There are many websites very well done to do that. So if you need to do this kind of thing, you can take that as an example. You just have to install some packages, run it, build it and run it, and it's okay. And it's running after. And after that, you can check that your device is connected to the sensor tag. For that, you will use the BlueGi tools that are included. HCI config is the command that gives you the status of the connection, of the Bluetooth connection. And you will do a LE-scan, which is a new command for the Bluetooth low energy devices that will detect all the Bluetooth low energies that are around the device. And the GAT tool, which is also a tool included in the BlueGi stack, gives you the possibility to read effectively what is in the sensors. So you can read the temperature. In this case, we are reading the temperature. I'm showing that because the bundle that is inside the Kura that I will use to do these kind of things is using these commands, actually. This is a direct call to the BlueGi commands. So now we are connected to our sensor. We need to install Kura on the Raspberry Pi because we will need to deliver this data to the cloud. So to install Kura, it's quite easy. You connect to the Eclipse website on the Kura web page. You can download the release that you need. In our case, we will download the Raspbian Debian package with the web UI because as I will show, we will use the web UI to configure everything on the device. when you have downloaded this file, you transfer it on your device, you install it as you do on all your Linux system, just using the the package, and after that you just have to reboot the device and Kura is running. So after a while you need to wait maybe 1 minute and 30 seconds because it's a bit long. It's a Raspberry Pi 2, it's not a big machine. You can check that Kura is running because you are able to connect to the embedded web server which is in Kura. So you just have to enter the IP address of your device and the Kura web page will open. You have a web, it's really comparable to a router configuration, this kind of thing, or to your live box for the French. You have admin as a user and password, and after that you access to the menu. So first thing to do is to make sure that your network is able to connect to the one. The one is the internet, so we are using DHCP in this case. Then we will start the configuration. To connect to the cloud, we will use, of course, Eurotech cloud because I'm working at Eurotech, but you can use another cloud if you need. You will enter the broker URL. You will enter your account credentials. Then you have all these parties embedded in Kura. All what is shown at the moment, you have it when you run Kura on your device. So you need to give a name to your device, and after that you just say connect auto and startup, and when you apply this configuration, the device start trying to connect to the broker. So after that you will check that your device is connected. The best way to debug on Kura is actually to have a live view of the logs. So you are tailing the logs, and you will see in the log that after a while your device will connect to the cloud. So okay, we are connected. So as you have an account in Everywhere Cloud in Eurotech, you will open your account in Eurotech Everywhere Cloud, and you will check that your device is effectively connected in your account. So this is the cloud part of the demonstration. Okay, so we have a sensor connected to the cloud at the moment. Now I want to publish the data. So by default, Kura doesn't know how to publish data from a Bluetooth low energy sensor. So you have to install a new application that you will have write for this case. You can use examples which is on the Kura GitHub website. There is a TI sensor tag example which is done for that. You import it in your Eclipse environment, and after you can generate what we call a deployment package. I will show a bit later that Kura is using OSGi, and it is using also a small tool which is called mToolkit, which gives you the ability to embed everything in the deployment package that after that you can deploy on your device with just one command. So you generate this small deployment package that is embedding your jar files, and the configuration files, and you deploy it on your device. For that, it's very easy. You just have to use the small web interface included in Kura. You open the package, select the deployment package file, apply it, and it's running, if you're lucky. If you're not, you look at the log. And after that, you can start to configure your device, because what is also interesting is that in deployment package, in OSGi declarative service configuration, you can configure everything dynamically. So all these parameters can be changed at any time, and it will be applied immediately on the device. So we configure the device. We say, okay, this is a CC2650 because there is 2 releases of the TI sensor tags that are not fully compatible, so it's very easy. The scan time that you need to look at the device, the period that you want to publish your data, and the topic on which you will publish the data. I will explain later the concept of the MQTT topic to publish data. So, as before, we are checking in the Kura log when we apply the configuration that everything is okay. So, well, this is a bit of cryptic, but in this log we can see that the deployment package is running and the device starts to scan to see if any sensor tag is is around. We detect the device, so we can see that at the top right, you see that there is a TI sensor tag in the around. So he starts sending the command to the device, and he starts reading the measure. So we can see that now he is able to read the temperature and the humidity, and he could do more. So we have the data. So now we publish the data to the cloud. So this is also a function that is embedded in Kura. The MQTT client that will publish the data is already present in Kura, is ready to publish. So as we have the data, we publish the data. It's just one line of code. And the data are stored on the cloud. So you can check after that on your cloud account that your data are published. Okay, so that's done. We are publishing data from the sensor tag to the cloud. So after that, you have to program some nice dashboards. It's up to you of what you want to do with that. Okay, so this is the part just to explain how we use Kura to publish data from the field to the cloud. I will go a bit deeper in what is inside. So we call it Eclipse IoT in action. It was last year a presentation. Kura is actually a full framework that is embedding all the parts that are needed to manage and to connect a gateway to the cloud. So it collects the data, it transports the data using the PIO. There has been other talks talking about PIO. PIO is the MQTT client that you will find in Eclipse Foundation. And it is, anything is founded on MQTT protocol. MQTT also is now a de facto standard in the IoT and is used very largely. The architecture is quite simple. We need a hardware, so it's Raspberry Pi, a Linux on the hardware, a Java virtual machine. OSGi is running on the virtual machine, and Kura is deploying bundles in OSGi. This stack is communicating with MQTT to a device cloud that we call device cloud. This is the Eurotech part of the installation. It's a Eurotech device cloud. The Eurotech device cloud is doing everything for storing the data and managing the device, and is giving the ability to all the consumers that need to consume these data to access to the data through the REST API or MQTT. And after that, this is the business of the customers. So this stack has a good advantage in increasing the developer's productivity, because everything is already in place. You just have to focus on the application. You don't have to take care of all the hardware management part and the communication and protocols. A lot of things are already done and working and very strongly debugged already. So we have inside a lot of management also part that I will show. This is all the parts that you have seen in the menu when we were configuring the device. For the developer's experience, it's very easy. So you download the Kura environment in Eclipse, start developing your M2M application. You can debug in Eclipse. You have some emulated service. You have support for many different platforms. So everything is done inside Eclipse. When you are ready, you deploy it on the target. using the device, the tools that I have shown, the mTools in this case, that is able to deploy directly from Eclipse to the device or to generate some deployment package, as we have seen, that will be installed on the device. And when everything is okay, you manage your device from the cloud. So inside Kura, everything is also already in place. So as you can see, we have the device abstraction, which is using mostly some already open sourced bundles. All the basic gateway service is also provided. So you have a clock service, which is taking the clock from NTP server. You have a position service if your device has a GPS, so it will be able to publish automatically its position. You have a watchdog that you can use if your application needs to be secure. You have all the network part is embedded also. So every connection that is available on the device can be already managed. You have the connectivity with the cloud, of course, which is also embedded. You have the PAO client inside and the data service that takes care of putting the data in the right structure and sending it to the cloud. There is also a security part that is not here on the graphic, but we are implementing now a security level that gives the device the ability to be more secure, sending the data in a secure way and to be authenticated by the cloud. And all the remote management and administration part that we have seen already to configure the application. And this is also, so when you develop on Kura, you have downloaded the Kura on the Kura website, the Kura package. So all these services are in the API, as you can see, and are already enabled. And what is interesting also is all the management part that we have seen, which is embedded in the web server, in the device web server, are also available on the website of the cloud. If you are using Eurotech Everywhere Cloud, everything is also enabled in the cloud. So you can manage your device from the cloud as you do if you are connected to the device on the field. Just a few words about what we do with MQTT topics. So MQTT is a publish subscribe protocol. When we publish a message on MQTT, this message needs an address, a topic. What we call a topic is an address as a URL, and this address will help us to make the sorting and to retrieve the data. So automatically in Kura, the MQTT topics are prefixed by the account names that you need to configure, and the asset ID, which is generally the MAC address of the device. After that, you have the application name. It's generally up to you to decide what kind of application you have. And the payload that is inside the message. So the message has a topic name and a payload. And in the payload, we define, this is Eurotech that has defined all this structure. We define a strongly typed payload. You can have a payload totally an array of bytes, it's not a problem. But it's very interesting to have an already typed payload because your data will be sorted automatically on the database side. So you can retry automatically the GPS position only, or only the temperature, only the pressure, of what you need. So this is strongly defined in the Kura payload already. Okay, so that's what you see on the right, which is the table that you can have on the Eurotech Everywhere Server Cloud. Okay, I think I'm done on this part. Now it's up to you to use, test Kura, and contribute if you need. Okay, thank you. Any questions? Any question? No?
in the end, you just mentioned that you have defined a set of vocabulary or data structure to library. Is it possible to extend this vocabulary?
Yes. No. What is already typed is the structure of the payload of the message. You define nearly everything. So you say, I am storing an integer. I'm storing a double, a float, or a string, an array of. So this is done already. You cannot extend this, but you can, for example, if you need to store a file, a video file, or a PDF or something, you can put it also in the message. Just it will not be listed in the list of the variables, because when you open in the cloud the messages that you have received from the device, you can have already all the values from all the variables that you have stored. If it is not an untyped variables, you will not have it, but it is in the message, so you can retrieve it also. But this is no, this is closed.
Do you have some examples about Kura applications?
Yes, you can come at the Eurotech stand. I can show you many examples, but yeah, Kura is okay. Solar is doing something with Kura. We have more and more now. We are starting more and more proof of concept, principally in industrial field. We are working in industry, transportation, this kind of thing. And I know that Kura is also now used in conjunction with other Eclipse projects. Apache Camel, I don't know if you know, Apache Camel is now including Kura in their connectors, and there are many now new projects that are using Kura as a basic foundation.
Do you have some permissions mechanism, for example, to say this device is only accessible from this IP or for this?
Yes. So it's inside the Kura implementation. You have an ACL implementation. So your device can connect to the broker if he is allowed to, and the cloud is connected to the device only if the device has say you can connect to me. So everything is coming from the device. There is no way to connect to a device that has not already say I am connected. You can call me. But yes.
Which broker software are you using?
We are using. We started with Mosquito, which is the open source implementation of MQTT broker. We are on the production side now. We are moving on AMQ, which is a Red Hat broker, and we are working closely with Red Hat at the moment on this part.
Is that open source?
I think yes, AMQ.
It is ActiveMQ.
Yeah.
And it is open source.
It is open source also. Yeah. It is open source. Yes. They're working with Red Hat on the debugging of the MQTT part of the ActiveMQ. Yeah.
How easy it is for your customers to set up their own clouds and to build their own environment?
If yeah.
Full stack
Yeah. If a customer that wants to test Kura, it's very easy. As I show you, you buy a Raspberry Pi, install Kura, everything is free, so it's easy. On the cloud part, if you want to make your own cloud, it will take you some years, because we are working on that for a few years. But if you don't want to spend too much time, we can also sell you this part, or there is some agreement. But this is not free, of course. This is not the open source part of it.
About the Bluetooth Low Energy service in Kura, is it fully compatible with all the devices?
Yeah, we are using, as I told, we are using the BlueZ stack. So if you can scan your device under Linux with a BlueZ command, you can use it in Kura. It's a direct call to the BlueZ stack.
Because the last version of Kura, if I'm not wrong, is compatible with Intel Edison.
Yeah,
so I
sure.
can use the Bluetooth Low Energy also with Intel Edison in the last version?
I think so. I never tried it, but I think so. I'm not working on the Intel Edison myself, but yeah, I think so. For example, you know the mini gateway, you know, that we have used. There is inside a Bluetooth Low Energy component, and this is working with Kura. With the latest version of Kura is managing Bluetooth Low Energy, is the 1.2 version.
Okay.
We just released it 1 month ago. Okay, I think we're done. Thank you.